By the end of today's lesson on Autodesk Fusion, you'll understand a wide variety of different sketch tools and types of different shapes that you can create in Fusion. For example, we're going to be making a self-driving robot chassis in this kind of classic autonomous rover shape. I'm Mr. Pratt, and I've been teaching CAD and robotics to students for over 10 years now, so hopefully some of the skills that I've been able to develop them in the years can help you develop some of your skills as well. We'll start today by showcasing the broad range of sketch tools available for you in Autodesk Fusion. We'll talk about the difference between construction, build lines, sketch constraints, things like that. And then in the end, we'll be able to make this chassis using some of these tools. So let's go get started. So the first thing I'm going to do is I'm going to go ahead and create a new sketch. I'm going to make this one on the XY plane for the top face of our rover. And then as we were in the last time in this tool panels, our tool now changes to the sketch interface. Now, this tutorial is predominantly going to focus on the create and modify sections. We'll talk a little bit about constraints, but we'll get a deep dive into constraints in a later video. For today, let's talk about all different things that you can do. And let's just start over with line. If I hover over a tool and I let my mouse rest for a minute, it's going to show me the kind of things that I can do. The line segment allows me to click at any point, start. And if I let go of my mouse, I can now start moving this around. I do not have to click and hold. You'll notice that Fusion's automatically going to try to give me some angled lines. If I click again, it's going to define another point. And then I have two options at the end of a line. I can either click again to put in another line, or I can click this check mark to be able to finish off my line tool. And this finishes off a line segment. All of these lines I should be able to click and drag to be able to change any of their lengths because they're all not constrained again. They are blue lines, so I can grab any points, any lines, and move them around to anywhere that I want. I'm just gonna go and select these and delete them. With rectangles and with circles, there are a few different options you have over here in the sketch palette. You can grab a 2-point rectangle, and a 2-point rectangle clicks from one side and then allows you to drag out to click to another point in any 4 quadrants. However, you can also use a 3-point rectangle. So you can click 1 point, select another sketch, 2, and then 3 to be able to make them at different angles. Or you can also select a center point rectangle. So there's different options for you to be able to make these different rectangle tools. The same is true of circle. You have 2-point circles, 3-point circles, tangent circles, 2-point tangent circles, or a center diameter circle. If you're not sure what a tangent circle is, what a tangent does is and for now I'm going to make a 3-point tangent here. A tangent is effectively a circle that touches a line at 1 point. So you can click on this line, and on this line, and we'll create a tangent between those 3 lines. You could also do another circle with a 3-tangent circle, and I could do this line, and this line. And that's actually going to bust out a little bit more. You'll also notice that when I put in that tangent here, there is this little symbol that shows up. And this symbol is a tangent constraint. There's the fit point spline tool, and this is kind of like the line tool. It acts the same way, but allows you to make different curve shapes. Same thing, you have to click check mark to finish it. But what a spline allows you to do is allows you to drag out the length of those individual lines, so you can get some really unique geometries using a fit point spline. You can reduce the length of those curves, you can drag them up quite wide, and you can get a lot of different shapes and so forth. We'll go ahead and delete that. You have mirror, we'll talk about that a bit. We've already talked about the sketch dimensions. And then you have arcs, where you can make 3-point arcs, center arcs, tangent arcs between 2 points. So for instance, if I want to have a 3-point arc here, I could do so to be able to make a 3-point arc. 1, 2, 3. I will undo that. You also have the ability to make polygons. So if I were to grab in my center point here, I could say a 40 mil, and then I could make an 8-sided, a 3-sided, a 5-sided, whatever it is you could choose. You can make a 20-sided polygon if you wanted to, depending on how large your piece is. You can also make ellipses to be able to grab these, and then you can change out the size of your ellipse. So you start with defining your width on one axis and then your width on a second axis. A slot is a really useful piece in robotics because rather than having two circles, it allows you to make a piece with a little bit of extra compliance. If you're not exactly sure where your piece needs to fit, you may want to consider using some sort of slot. There's a center slot, we'll talk about that. So let's say I put one center over here and I say 8 times 4, because I know that my Go Pilda pattern is 8 millimeters across. That assigns my distance, and then I can say a 4 millimeter hole, and now I have a nice 4 millimeter slot that is 32 mil center to center wide. So it actually ended up being about 32 into 4, 36 from edge to edge. You can also create slots from center to center. An overall slot, we start by defining its width, a center point slot, a 3-point arc slot, or a center point arc slot as well. So there's lots of different, let's show you a 3-point center slot here. So you could do a slot like so if you wanted to be able to have a curved piece. So you want to be able to change the angle of it once you've mounted. Center point slots are quite useful for that. We've already talked about splines, conic curves you can draw in. You can add in specific points. You can also add in text, things you want to. It works the same as you would on, say, any Microsoft Office or Google Docs. You just drag your bounding box, you type in your text, and then you can add in, of course, your lines and so on, what have you. You can change heights of text for how tall you want it. Oh, that's 500 millimeters. Let's make it 5 millimeters. You can change your font. There's lots of different fonts that exist. I believe these fonts are just the same as you have on your computer. So whatever you've got access to on your computer, you should have access to on Fusion as well. If you want to change the size of your bounding box later, you can always grab your corner to change where you want these to be. There's also a circle and rectangular pattern. These work the same as they would in the last tutorial. So for instance, if I were just to make a quick circle in here, make it 4.3 like we did, you could also do a rectangular pattern of sketch objects. Now let's say I want to edit this rectangular pattern. If I click on the first circle, you should see that the rectangular pattern constraint shows up. If I double click on it, I can go ahead and I can edit that initial rectangular pattern. Now, there is a danger with using the rectangular and circular pattern in sketches, and that it's really going to slow down the performance of your models. And Fusion says it's best practice that you should make rectangular patterns for simple sketches, and then instead you should mirror them out as solid bodies instead. But for today, I'm just showing that you can do this in the sketch interface, but it's recommended that you don't do it inside the sketch interface. Although that's something you're going to find about Fusion is there are 1,000 ways to skin a cat. Lots of different ways to do the same task. For instance, you can make a circle here and then extrude it out. You can also add the built-in sphere feature, you could also use the built-in cylinder feature on extrudes. There's lots of different ways that you could do things. It just depends on what your specific workflow is. However, for rectangular patterns, I recommend you only do simple rectangular patterns inside of a sketch. I'm going to go ahead and add in a quick rectangle here. I can press R on my keyboard to be able to put a rectangle. And then I can also use a fillet command. So you can fillet specific points, just like you do on solid fillets. Again, it's recommended that you do fillets on solids as opposed to fillets in sketches. So if you're going to do this in a sketch, you should make it a little bit simpler. You can also add in an offset. So if I were to click on my outside line, I can go ahead and drag in my offset tool. The nice thing about offset is that it's going to match whatever changes I make. So the offset automatically propagates over on what it is that I'm choosing. Oh, that's a really funky shape, making that a radius of 80. Let's make it back to 20. Oh, that's still a little funky. Let's make it 10. All right. So you can still offset these pieces in and change them up quite a bit. Now, here's a perfect example why I might want to use the trim tool. You'll notice that my corners get a little strange here. I can go ahead and grab this trim. What I can do is I can cut out specific sections of line shapes or line segments that I don't want to keep in. So for example, let's say that I were making a plus. I grab two rectangles and I grab another rectangle and I want to be able to pull out the plus here. I'll grab my trim tool. I can go ahead and cut out the center sections of my plus. And now I've got a single face that I can work with that makes my modeling life a lot easier to select a single face. There's also a few more tools like breaking or extending specific lines, but in my experience, we don't use those too frequently. You can also move around sketch objects, but again, I don't find I use that too frequently inside of the sketch atmosphere. So let's go ahead and select everything, and we'll go ahead and delete. Now while we're at the select, there's actually two ways you can select things in Fusion. There is a dragging from the left to the right, and there's dragging from the right to the left. If you start from the left to the right, you notice it makes an orange bounding box. If you start from the right to the left, you'll notice that it makes a yellow bounding box. Now, the orange right to left means that you have to completely surround an object to be able to highlight it. So for instance, I'm completely surrounded my polygon, but I have not completely surrounded my ellipse. I'm only going to select geometries that are inside that selection. I've got these points here as well as the full point. However, if I were to start from the right and go left, I'll make this yellow bounding box. If I let go, anything that is touching is going to be selected. So you notice that we select this face, these specific edges, but not all the lines. So let's go ahead and select everything, give it delete so we get a nice clean workspace. And now we're gonna get started building this base model here. So this is the shape we're gonna try to recreate today. And we're gonna do this by using some of those mirror tools that we talked about we haven't had a chance to take a look at yet. So what we're actually gonna do is we're actually only gonna draw one corner of this today. And then we're gonna mirror it over to make the other half. And then we'll mirror it over again to make the last half. So let's start by drawing out that corner. I'm going to start by grabbing out my line tool. And because I want everything to start from the center, let's start by going about 30 centimeters in. So now this line here, I don't actually want to be a real piece of geometry. For instance, if I were to put a 2-point rectangle over top of this, you'll notice it actually splits this into two faces. That's not what I want for this case. So I'm going to go ahead and select the line. On the right-hand side, underneath, I'm going to select construction for my line type. Now, if I were to take a 2-point rectangle and put it inside, you'll notice that it only selects one line, and it doesn't actually split this up into two faces. Because it is a construction line, it's used as sort of a dotted or a dashed line as a guide or a template for you, but not actually a line. I'm also going to go ahead and draw my center line at this point. So I'm going to go up and grab the line tool, go back to my construction line, and we're just going to choose a random height for now. The height doesn't actually matter at this point in time. Now I'll grab my line tool, turn off construction, and we'll draw our line up for half of our sort of motor cutout area. I might make this 30 millimeters. Then I'm going to move out by say 15 millimeters so I have enough space for my wheel to fit inside of this cutout. And now I'm going to create an arc to these top points. And now's the time for me to decide how long I want my rover to be. Because we're only drawing 1/4 of this, I need to decide how long I want this to be in total. And now I can go ahead and make my dimension here. So let's say that if this wheel cut is going to be 30, maybe I want my rover to be 120 divided by 2. So that because right now I'm only driving half of it. So in total it's going to be 120 millimeters long, but right now it's only going to be half. You can also do math inline on your sketch tools, which is really handy. Again, I'm going to make this one a dashed line. Now I want to draw an arc that completes between these two sections here. To be able to do that, I could use a fit point spline, but I don't know where that center point is. I could use a center circle and draw from this origin and circle out, but I'm going to use the arc tool and I'm going to use the center point arc. In order to find the center point, I'm going to go ahead and just hover over this corner, and as I drag over, you'll notice that Fusion's adding a nice cut line for me to be able to find that piece, and I can start with my first center point, click for my other next point, and then I can drag out to have my third point actually defined up on the top of my rover here. And now you'll notice that I'm probably going to be a lot longer than it is that I expected. So perhaps I don't actually want to use that as a center point. So let's go ahead and delete that constraint. If I select my arc, you can see that I've got my center point starting down here. If I were to drag the corner down, my center point changes itself over. And right now I would like these 2 points to touch, but I like my center point to actually be over here. So I'm actually reduce the length of my curve a bit because I want it to actually be 60. So I'm going to go ahead and go up here to my constraint section, and I'll go into coincident. What a coincident does is it constrains 2 points together along a line. So if I click on this, grab that center point, and then grab my pointing line, it's actually going to pull my center point back, and now I've got a curve that it is I'm looking for. So this is that start corner of my shape. Because we put in all these constraints, I can go ahead and I can change any of these sizes that I want. I could say make this 150 and it automatically updates the rest of my sketch. Let's undo that. I could say add this in 20, it updates the rest of my sketch. And for this one, I could even make it longer. Maybe I actually want my whole base to be 150 long, and it will change the size of my sketch. Let's go ahead and mirror this over. Up on the sketch tool, I'm going to go ahead and select the mirror panel, and I'm going to select all the geometries that I want to mirror. In this case, it's just these 3 lines. With my 3 objects selected, I can go to mirror line, and now I can select this center line that we drew earlier as my mirror line, and you notice that it automatically mirrors my sketch over. You'll also notice that we have these new constraint points added up, and these constraints are called symmetry constraints. They look like a little window, yeah? So when I hover over one, we can see which 2 parts are symmetrical with one another. So if I were to go ahead and change one of these designs to say make this one 25, you'll notice that the other side also changed because as we mirrored it, it's going to try to keep it symmetrical. Let's go ahead and mirror this over one last time. So I'm going to grab the mirror tool. I'm going to go ahead and select all of my geometries. And for our mirror line, we're going to select this bottom line that we drew earlier. And now we've got our center point of that. And here's our total piece. Now at this point, I'm thinking this is probably a little bit thin. So let's go ahead and let's change this to maybe 50. We'll update the width of it so we can actually have a more circular design. And that's looking pretty good for our autonomous rover. So I'm going to go ahead and press the extrude tool, grab my face, and let's bring it up 4 millimeters because that looks about right for a 4 millimeter ply. And you can now see we've got our bodies. Just as the last showcase of our parametric modeling, if I were to go back and edit my sketch, I should be able to change the width of specific things. So let's say we want to make this a much deeper cavity. Let's make it 25. So we have a much wider wheels by chance. Finish the sketch. Notice that it automatically propagates over. So hopefully you found that useful in a quick overview of all the different wide sketching tools that are available for you. Next tutorial, we're going to get deeper into the extrude tool as well as talk about some combined tools to be able to make your own compliant or squishy wheel for a robot. Best of luck on your next robotics project, and I hope to see you again in the future.